we're going to go ahead and get started. We're going to be diving into how you can scale your detection engineering and really get it started. If you haven't, if you're in the audience and you've already adopted and implemented detection as code and have been able to scale your detection engineering, please raise your hand or just put a little reaction in your box. Love to call on you throughout or get some more information. But if you are here to learn how you can do this, and as well as leveraging AI and machine learning for workloads on Snowflake, this will be helping you. We'll go through how this can dramatically reduce costs, but also be a super effective way to scale detection engineering for you. I'm joined by Mike Hart, who is our principal detection data scientist. We should be calling him Dr. Hart, if you will. So Mike, I'm gonna let you introduce yourself.
All right. So my name is, yes, I am a doctor, but my wife is the actual physician here. So I'm principal data scientist here at Anvilogic, right? I'm based out of Hartford, Connecticut. I was also a technical director at Semantic Research Labs a while back. Oh my goodness, it's been a decade. I used to review mail through Gmail at Google. And yes, I earned my PhD in computer science at Stony Brook University, but my wife's the actual doctor. She is a physician. So yeah, so today in our talk, we'll talk about bringing your own data lakes, because we know that for a lot of customers, including yourself, right, your data is resident in multiple different, places, right? It could be in CrowdStrike, it could be Amazon, right? Where have you. And what we want to do is talk about how we're able to take our customers' data lakes and apply machine learning to threat detection and response. So basically, what I want to make sure is crystal clear is that I don't do machine learning specifically on the raw data. Rather, what I do is I take the detections and then apply machine learning after the fact, right? And that we leverage AI to scale large data workloads. We try to filter out the noise. And I'm going to show how we use, language models to basically running on Snowflake to be able to automate investigations. So we can pick up things, for example, like we'll demo today, which is detecting malicious PowerShells. So let me bring up this slide right here and hand it back over to Jade.
Yeah, thanks, Mike. So really, as Mike was saying, being able to do this quickly and being able to bring it on your own data lake and kind of adopting a seamless architecture really is going to allow you to be able to reduce costs, do faster detection engineering and tuning and maintaining, as well as just get overall better coverage and better security to reduce your risk. We're dealing with a lot of manual processes here when it comes to detection engineering. Maybe there's a lot of multiple people involved, platforms and tools, always resulting in a really slow process and disjointed, typically poor correlations. And then we get the data lake layer or the logging layer, and really most people combine these two, the analytics and the logging layer. So what we're saying here is, don't do that. We're going to go ahead and decouple the analytics and logging layer. So you can just, instead of pulling into some monolithic platform that can be incredibly expensive, you're going to be able to bring your own data lake, bring whatever platforms you have, easily migrate those detections over to other platforms, but really get this holistic view and democratizing the detections across all of your data lakes or platforms to really start to adopt this seamless architecture. We're going to also be able to ingest through API all of your all of the vendors that are creating other alerts and bring it into Anvilogic, where the detections are going to be done for you, normalized and enriched. So you're not having to hire people that are code or tools experts. We're going to have that in a normalized fashion, tag it, and escalate the alerts that matter most. And a big piece of this is because this Copilot is generated by AI. I'm going to hand this to Mike because he's really a big brain behind how we can really automate this process for you and get you to reduce time and save money.
Exactly. And really, like, one of the key components, it all starts with our armory. And we have a lot of people on this call who are responsible for that content, right? And it just makes my life easier, because what they're doing really is building out great security detections that go into your data lake, right? Look for IOCs and other, malicious, suspicious behaviors, right? Brings that back into our platform. And then I'm able to do machine learning on top of that, really to kind of surface the most interesting, most interesting events and detections from there. So as you can see here in the top left, right, we have your data lake. And what we provide is insights, right? So we want to figure out how we can tune your detections. That'll be a future talk. Health alerts to see if things are broken when you're trying to deploy things on your data lake, right? Because it happens, right? Sometimes, queries fail, and we'll be able to detect that, as well as give you opportunities that if we find something interesting, we can triage and hunt. We can basically triage, any potential detection, as well as give you the capability to hunt, right? So as you are building out these detections, you may have, quite a few of them, and we have tools for you to be able to deep dive into those. So the way that we do that is by leaving your data where it is. If you look at step number one over here, once we've been able to use your particular data lake, right, we can basically persist the data. And the way that we do it specifically to adopt this sort of SIMless philosophy, right, is to basically run the detections, use the mechanisms of that particular data lake, right, to generate the detections efficiently. And then we can persist them to a basically, object store. And we use in this case, in this, diagram S3, right? And from S3, what we're able to do is use Snowpipe, which is a data ingestion tool from Snowflake, to then basically put them into event tables that then I can run my models on. And really what is nice about that is that I don't have to figure out like, okay, how do I run this deep learning model on Splunk, as well as, try to run in Amazon or what have you, right? All I need to do is I get the detection results, right, from, that particular data lake. It gets extracted, loaded into Snowflake. We do normalize and enrichment. And now I have only one place where in one platform where I actually have to do the machine learning, right? So I don't have to try to push it to multiple data lakes. I don't have to try to figure out how to deal with specific vendors. Because if you take a look at the bottom left here with CrowdStrike, Wiz, Sentinel, and others, right? It's very, I could create something that pulls all that data and then runs. And that sounds terrible, right? What we do is we create integrations that comes into our, basically our hunting and detection platform in Snowflake. I can run my models, and then what we can do is have one point pane of glass where you can see those, insights, right? Be it a hunting insight, and then from that jump into a triage or even a hunt scenario.
So just to let you know, this is part one. So this is really that overview of how can you implement machine learning? How is the underneath guts working? And then part two and part two is going to really dive into this AI insights around tuning and health. We'll touch on it a little bit today, but that tuning is going to be in part two, and we'll be deep diving. And then part three is really going to be a deep dive into that health escalation. So just wanted to let you guys know that to stay tuned for the next ones. But I would say that a big piece of this is the benefits that you get out of adopting the SIMless architecture over time. So I'm going to, Mike, if you want to go into some of these specifics so from a SIMless architecture, you're being able to get the most out of your data where it is. You're not spending costly things, but one slide back, Mike, will give you what the SOC Copilot really gives you out of all of this once the data and the alerts are in Anvilogic.
Exactly. And one of the things is that now that we have everything sort of resident on one platform, right, that we have effectively created this alert lake, right, we're able to then bring in, heavyweight tools like generative AI, right, to be able to do more with that particular data, right? So for example, automate investigations. We also take the detections and we try to rank them, right? We try to figure out if you only had, 10 minutes to look at your detections, right? What would be the 5 most interesting, events that were created from your detections, right? We also take advantage of a lot of the great research that our, threat research team does and try to detect, high fidelity, alerts and attack sequences based on threat research that they conduct. And then the big thing too is, look, any detection you put out there, they're going to be false positives. And we have ways in which we can use generative AI tools, right, to basically, look for and identify true negatives or things that are not security relevant. So, and that all gets into our security lake. And there's one place in which that can be pulled and then be used for triage purposes, hunting purposes, or even escalate to, some sort of remediation action.
And even this setup is pretty low lift for teams. A lot of our customers and people that we're working with today are getting started reducing false positives within their first week or two. So this is a relatively low lift for your team to start getting set up. And because of the machine learning and AI and all this tagging, you're not having to do a lot of this upfront work that you normally do across new platforms.
Exactly. It just makes, for me, like one of the great things about having the seamless architecture is I don't care where the data comes from, right? It comes to me basically as I need it in a schema, right? And then I can conduct basically and have a single platform for which that I can build against, understand how to deploy these machine learning models and be able to drive value for our customers.
And Mike, I know you're going to get into this, but and feel free, I know you're tired, not to answer this, but I am wondering, how can people trust that the underlying machine learning is actually serving up the right fidelity alerts and not missing them or actually doing the automation? And I think you'll probably get into that throughout this presentation, but how do you trust it?
Well, I think like the biggest thing is that it really requires a lot of painstaking research into like what am I trying to detect, right? How to ensure that like I understand the model understands what is the mechanism of malicious behavior, and then really trying to identify that. And I think it's tough, right? There's no perfect predictor. Like I haven't met somebody, I mean, for example, if you let your Tesla kind of drive you around town, it makes mistakes, right? So there are situations where, yes, absolutely, the models themselves, like humans, are fallible, right? But where I think we have that trust or can build that trust, the output from these models is worthy of looking at it, right? Is not only the fact that, we have great partners like on the data science team with our threat research group in order to help make sure that we're looking at the right things and we understand basically how these attacks manifest. But in addition to that, we also get customer feedback. And because we have one simple platform where I can, if I get a suggestion from customer or feedback from customer, right, I don't have to change multiple things in multiple places, right? It's just in one place where I change my one model, right? And I can incorporate that feedback and deploy it very quickly.
Feels like the upside is better than the not trusting side. I think, the machines can definitely handle machine level of data more than a human. And I'm sure everyone chases these false positives all the time and spends too much time in there. So if we can get that high fidelity alert more often than
exactly
not, I feel like it's a win, and we can continue to move forward as machine learning and the data science grows.
And one thing is like, everyone's talking about this co-pilot, terminology. And what I actually like about this metaphor is at the end of the day, you, the customer, the analyst, are the captain, right? You're really in charge of flying the ship. And really what we want to do is try to make you as efficient and as effective as possible, right? And to do that, right, we have, as you were saying, Jade, right, there's mountains of data, right? Even some of the best detections that we have, right, will still generate a lot of output, right? So how can we help you mine that as quickly as possible and surface the most interesting things based on our current understanding? Is a challenge, but that's a whole goal of the co-pilot, is really to help you and be next to you, really help you fly that plane.
Yeah, and I feel like the perfect analogy is these self-driving cars. You have the Teslas that you're still in command, you have the co-pilot. But in San Francisco, we have a lot of self-driving cars that freak me out still. They drive by and there's no one in the driver's seat. But I am actually more confident that self-driving car with nobody in it would stop if I stepped in front of it more often than a bus with a human driver would stop. And so we don't want to get into the specifics. I'm not trying to get into any type of, I don't endorse it, and neither does Anvilogic on one side or another, just an analogy of how with security, adopting this kind of seamless architecture and using the co-pilot could eventually help and lead you to a lot still maybe a co-pilot. We're always going to need the human, but moving towards letting humans do what humans do best, and the machines can continue to do what they do best.
Exactly, exactly. So should we get into how we,
Yeah, like how do you apply this? Like
how
this
we
all sounds good. Sounds like a lot of salesy, cool, Anvilogic, marketing pitches, but this is real stuff. And let's get into how you can actually apply this machine learning through threat detection. What are some of these challenges and the solutions that come along with implementing what we're talking about here?
Excellent, excellent. So I think one thing we have kind of touched on a little bit, and I'll just go through this slide pretty quick, but basically look, right? If you do machine learning for cybersecurity, you're familiar with the scaling challenge. It's not just the data, right? I mean, there's just basically like the types of problems that you need to solve tend to be different, right? Some of the solutions can be unsupervised, supervised. Maybe you need natural language processing to be able to even just help normalize and extract things of interest. We also know that, look, attacks tend to present themselves as anomalies, right? So it's very difficult from a machine learning perspective, particularly for cybersecurity, when you have absolutely plenty of benign, non-security relevant events happening in your systems, but those actual malicious samples can be few and far between, right? And we're also dealing with a lot of different personas, right? Like if you're building out these machine learning models, right? You need threat research to understand like who is the person that's trying to break into your organization, right? You need to be able to also say, look, if we're working with your threat detection team, how do you incorporate that feedback quickly, right? How can I deploy their insights about what are useful models, right? And get it back into the system as quickly as possible, right? And then the other thing too is like, threats are constantly evolving. I love what's coming out of our armory and our, threat research, our Forge reports, because again, these are all things where all of a sudden there's a new attack vector. And that may mean I need to try a different type of machine learning model, right, to be able to most effectively capture or understand that behavior. And of course, false positives are always a problem, right? Because we don't want alert fatigue, right? Like it's very easy. I can create a very noisy machine learning model. I could say, hey, that's great. But, absolutely, we don't want these things to be just random noise machines, right? We want them to help you be your co-pilot and really drive you to the most interesting alerts that are in your system.
I can't wait until we don't have to have the alert fatigue problem or that problem addressing. Everyone has different problems, but alert fatigue should not be one of them. I do think that as you look at attack vectors, and as you were saying, every organization is very different and has different needs. Sure, you can go out and get detections. You can understand what people are doing within your vertical and industry, but adopting it to what is most critical to you is what we want to get into here, and how you can adopt that machine learning specifically for your Snowflake environment, both security being the Snowflake as well as your Snowflake platform.
Exactly, exactly. And let's talk about how we actually use our Snowflake platform. So one of the things that I've come to really appreciate is that, in terms of our MLOps pipeline, like how do we, before we even talk about the models themselves and what we're detecting, right? Like how do we get this stuff out there, right? And what I found is Snowflake is fairly easy to work with, right? And specifically, and again, these patterns are not just specific to Snowflake, but these are how we use it. And if you have something like a data warehouse, then basically what we're describing here is applicable to your use case, right? So it all starts with Bitbucket, right? Because, although we're data scientists, right, we also write software. So we need, code, basically repositories to keep our code, make things are checked. If there's a problem, roll it back. So from our Bitbucket, we have pipelines, and those pipelines, publish basically 72 tables. We have tons of procedures, UDFs, and schedules that effectively do our detection. So as our, alert data, our detection data flows into Snowflake, right, we're able to do is start mining that for what are the interesting detections here, the ones that we should surface to our customers. So that's basically this detection that we're running on top. And those detections are run via schedules, procedures, and UDFs. I'll get into that later. For training, what we do is some of our models do require specialized hardware, right? Basically GPUs. So what we're able to do is after we do our own ETL, we're able to create training sets from those scheduled jobs, right? Put them onto S3. We train them on, we are able to run SageMaker training jobs. Once we have the model, we can push it back to Snowflake. So the nice thing is that because we use portable data, machine learning formats, right? Onyx as well as TensorFlow format, right? We're able to train on SageMaker, bring it back on Snowflake, and then hopefully, conduct a little bit of magic, right? But effectively, the nice thing is that even though it's running on a different architecture in, a different cloud or account, if you will, right? We're able to bring that back in and use those models as part of our detection, right? And once we do find something that is interesting, we use API gateways to basically, notify our Anvilogic platform that for this particular customer, we have found a detection. But I should say that what I like about this particular pattern is, particularly if you are in a case where you do need to use GPUs, right? Or maybe you need to do inference, low latency. What a lot of these, for Snowflake and others, it is possible that whatever your, cloud of choice is, you can persist the data temporarily to an object store like S3 or Azure Blob, and then use that cloud specific machine learning services, but that will all come back into your data warehouse. So again, this is just something that is dangling off our Snowflake just to enable us, or your data warehouse, allow us to be able to train these models efficiently and then be able to run the detection and inference entirely within Snowflake to generate our alerts. So
if I'm understanding it correctly, this is really about the process in which we do it. It doesn't really matter the applications or widgets that are there. And obviously we're using this in Snowflake because we're seeing the value out of using Snowflake.
Exactly. And just like the value that we have in Snowflake specifically, comes to basically the containerization of our inference, right? So we're able to, be able to, use different libraries. I'll get into that. But also like a lot of these warehouses like, Databricks, Snowflake, have the ability to do ETL, right? Using MapReduce and other, techniques. So that's the nice thing. And again, we're talking Snowflake specific, but it's not only Snowflake. We find that this kind of warehousing approach works well. And I'll go into specifically, things that we do in Snowflake, but they are applicable to other platforms as well.
You did touch on the why you're doing it this way. Is there any other reasons or maybe ways people are doing it today that this makes it and this process makes it a little bit more effective for people?
Well, I think this particular process is great because we can enable other partners, particularly like our, threat research team and our hunt team, to be able to do ad hoc queries, and we can push not only our code so that they can run their queries with our machine learning inference code in just a simple SQL query. But as you'll see, we also have the ability to use UI capabilities in Snowflake, right, to present our results. Excellent. All right, so let me go through and we'll go to the next slide here. Okay, so the way that I want to tell a story, the story is about my coworker, Tudor, and basically the way that he was able to do effectively, internet IP address extraction kind of encapsulates the story of basically you doing machine learning operations on the Snowflake data cloud, right? So one thing that we notice is, look, as you know, right, you can use a regular expression to identify IP addresses, but those regular expressions also are able to pick up, for example, versions of software. So what we found was look, we need a machine learning model. So we said, we have a hypothesis. Maybe we can use a character-based convolutional neural network to basically say, here's the IP, here's the text around, or a potential IP, here's the text around that IP. How do we detect it? So what Tudor was able to do was he created, using Jupyter notebooks, right? And we have our own little Docker stack, but basically using the Snowpark feature of Snowflake, right? He was able to do some research and validate that, yes, if we run a pretty efficient small CNN, right, we would be able to reliably detect that, yes, this is an IP address. It's not a software version or some other random numeric string that looks like an IP. So once we were able to do test our hypothesis, validate that this model will work well, right, we're able to use write this unit tests and develop the code in Python using Poetry for dependency management, right? So Poetry is a nice tool, and what that allowed us to do is make sure that we were using the same software that runs on Snowflake, right? And then what we do is we deploy this particular model as UDFs, procedures, and schedules. I'll go into those individually via CI/CD, which is our Bitbucket pipeline, and using SnowSQL to create the UDFs. And then what we do specifically is we call stored procedures to create basically our data frames, and then the UDFs actually themselves, so these user-defined functions, right, actually do the inference. So we're encapsulating the machine, the logic or the machine learning model in a UDF. It's not in the stored procedure. The stored procedure is more of just a way to create a data pipeline, ETL process, if you will. And yeah, basically we leverage our Snowpark UDFs for ML inference. So any questions on this, or should I go to the next slide?
Yeah, you might be getting into it in the next slide, but you had been talking about getting insights and all of that SOC Copilot things. How does this manifest in those insights?
Exactly. So all of let's say if we're looking for malicious PowerShell, suspicious, run DLL. So basically that machine learning logic exists in that UDF. So kind of like any other UDF, like if you could think of like in SQL, like array contains or string contains or anything like that, we actually create a machine learning model that the interface for not only our internal users, but also our own detections is just that user-defined function that does the machine learning bit on the function, the arguments that are provided to that UDF. So by doing that, not only is it something that internally we can use and people can test and try in their own queries or using the Streamlit, the user interfaces that's provided by Snowpark native apps. But in addition to that, we can also use that in the detection logic. So we have schedules that will then basically get the most recent data and then use those UDFs to apply the machine learning model for whatever attack vector we're interested in. And that will eventually generate, if we find something interesting, that creates the insight that we publish to our platform that our customers will see.
And I'm assuming you don't need to be a data scientist or a machine learning expert, because you're doing that on the back end and offering it up on the Anvilogic platform.
Exactly, right. So no expertise required, to take advantage of these particular models, right? But this sort of pattern is something that, like, if you're looking at evaluating Snowflake, for example, for your own organization, right, or for tasks that you have to do that, go beyond just typical cybersecurity detections. Like, for example, when I worked at CVS Health, right, we had a lot of fraud use cases. That basically this type of pattern is also applicable and allows you then to basically give something to that fraud team that, hey, here's a model that detects that suspicious behavior, but it's in a way that they can easily consume it, which is basically within SQL using user-defined function. So let me go on to the next slide here. And we have, okay, so why we sort of chose machine learning inference in UDFs, right? So the way that we decided is that, look, for each problem, we find that, there's different libraries that are useful for solving that particular problem. So for a lot of, classification tasks, people use XGBoost, right? But other people might find that using, Keras with PyTorch or, TensorFlow is more their speed, right? And basically, we don't want to limit our data scientists to what models, what libraries they have to use. So basically what we found is that, particularly in Snowflake, UDF is effectively a Python function, which makes it easy to unit test. And that because we use common libraries, we can reuse the same model loaders. And that basically what will happen is in our Snowflake, our models are on what are called a stage, just a simple file system that is accessible by Snowflake, Snowpark, and Snowflake SQL. And that whatever libraries they choose is totally encapsulated. There's no sort of dependency, management issues where, like, oh, hey, NumPy uses this, version. Actually, Pandas uses this NumPy, but this other library uses an older version of NumPy. Nothing like that. So it's very nice. It's very clean, and basically they can effectively do what they want, right? Use the type of model, the library, as long as they can write a Python function, which hopefully most data scientists, if not all, are able to do. Then they can use the procedures in SQL to basically register these UDFs and monitor for failures using the task history table, and then be able to publish that UDF that executes their model fairly seamlessly. And what we found is that Snowflake is also very efficient. So for our cases, by taking this particular structure, right, we are able to actually use extra small instances to, because the models are fairly efficient, and Snowflake as underlying platform itself is very good at sort of optimizing queries. It's easy for us to run these workloads without having to spend a lot of money on very pricey, overpowered warehouse instances. So that is, in a nutshell, how we're sort of encapsulating this machine learning inference, using the UDFs.
And the different libraries are used for different things, obviously, and you kind of listed a few at the top. Are there any specific libraries that you wouldn't use, or bringing in multiple libraries? Like, how's that?
I would say that, it's very tough. So I don't want to name names, right? There are libraries, I wouldn't use because, I think that you can find better, there's a lot of machine learning libraries out there, right? Particularly in Python that intersect in a lot of different things. But for me, I prefer Hugging Face. I prefer TensorFlow. I know a lot of people use PyTorch. I don't use PyTorch itself, but the nice thing about this particular pattern is, if someone, for whatever reason, is just bent on using a specific library, they have that capability. And again, at the end of the day, they have to prove that their model is not generating random noise, right? And if they can do that with their library, and it's in the Anaconda Python channel, right? So it's a supported library by Snowflake that's been tested for security, then good luck, right? That's what I would say. But no, that's the nice thing about this is that what we find is in security, you tend to require different solutions for different problems, which means you might have to use, you basically need a Swiss Army knife, which is what these UDFs allow you to do, is use the right library, the right model for the right job.
Makes total sense. Is there a way to look at libraries and understand how they can function together, or kind of just a high level view of when you're looking at them, what's going to work for what you need?
I think absolutely. So I think that the nice thing about with Snowpark is you would be able to, in either using Snowpark worksheets, or even running Jupyter locally, right, or in SageMaker or what have you, is you'd be able to get that data, evaluate, if these particular models, work well, or implementations of those models work well for your specific requirement. But then the nice thing too is, like, if you wanted to daisy chain models, right, one difficulty could be is that if there is some sort of dependency issue between different libraries, because they're using their dependencies depend on different versions of the libraries that might be incompatible. The nice thing about the UDF approach is that you can say, look, here's the machine learning model I want to execute. It's going to have some sort of output, right? It could be a number, it could be a label, it could be or even a piece of text, right? If it's generative, right? That can be passed on to the next model. And that next model can operate even if it has incompatible libraries with the previous model, right? Because we're able to effectively encapsulate it in the UDF and treating it really like a container.
I mean, obviously, these are all generating a lot of noise, and you're getting your alerts out there, or these are the models, and you're getting your alerts built off of these. How do you, with all of this information and knowledge base, get the high fidelity behavioral alerts, that you need to actually take action on?
Exactly. Really, I think it's about having a sensible process. And I think the first thing is, once you first have a data set and you're confident that that data set represents, the actual thing that you want to detect, right? At that point, generally speaking, from my experience, right, just been doing this since 2005, right? You definitely, once you find that data set, you're confident that it represents what, the malicious activity, and you have good examples or negative samples of, benign activity. Generally speaking, I find that it's good to then do some sort of thresholding on that model to determine, like, okay, what is a false alarm rate that I can live with, right? So basically, for every 10 true positives, can I live with one false positive? Or is it more like, I have to have 1,000 true positives and one false positive, right? Something like that. So once you get that ratio, you feel confident in that, then I let my model get beat up internally, right? So I show people inside, say, hey, is this detecting what you think it is? And what I really appreciate is my colleagues are very nice, right? And they're very helpful, and their insights into what I'm producing allows me to go back, repeat the process until I feel confident that if they're happy with what they're seeing, then I can push it out to the customer. And I think really the big thing too is monitoring, so that if you find that, for example, your detection is generating a lot more or a lot less than it has been, there might be some sort of data drift, and that's something that you would have to address, and that could also have an impact on the quality as well. So those would be the factors that I would have to really be confident that this particular model is generating high fidelity alerts.
Makes sense.
So I think what I will do is, any other questions on the call, and I can actually go into sort of like the kind of threat hunting that we do on the detections themselves.
Yeah, I think the threat hunting, and then get into testing those malicious PowerShells and showing us how it works.
Exactly. Let's get into it. So basically here.
And just a reminder for everyone, there is a link in the chat. If you have any malicious PowerShell that you want to send over for Mike to test, put him to the test. We'll be doing that in a few minutes. So definitely get him any of your PowerShell commands.
Exactly. So these are some example of the high fidelity behavioral alerts I've kind of modified that we've been able to detect with our particular platform. So the first thing is, all of these alerts are coming from our detections, right? From our armory, to say like these are run DLL, WMIC, and all of the that you're seeing here start with a threat, a content engineer, creating a detection. It gets deployed into that data lake. It comes back into our platform, and then we're able to surface the most interesting of those detections, right? So here, there's some nonsense. The first one with PowerShell, where we're executing some script, we're outputting it to a share. We got run DLL, executing the DLL you've never seen before in program data, which is not good because we know attackers like to store things there. With an unusual function name and strange arguments. We see here a discovery command like WMIC, basically enumerating for a customer basically what kind of their security posture. And then this is one I love at the bottom, is we do a lot with IPs, but generally speaking, like when you go and type into your web browser, generally speaking, you're using SSL, right? So you're not using HTTP, right? You don't typically put an IP address, right? You don't contact usually a port over 1000, right? And you don't download bin.sh from some random IP on the internet. So these are the kind of things that we have those detections, right? They run on the data lakes. They come into our, detection lake or, our alerts, right? And then we're able in Snowflake, and then we're able to mine and try to find the most interesting ones to share as hunting insights to our customers. So cool. So I think yep. And then just one last thought, again, this is me just showing, hey, we do lots of fun, cool things here, but, to do the threat hunting, right, we extract entities, right, IP domains, URLs, executables, and command line arguments from the detections, because again, sometimes you're going to get data from your data lakes that's not fully parsed, right? There's good stuff that's in the process field that just doesn't get pulled out because, Windows security event logs won't do that. We use text classification using large language models, like looking for malicious URLs. We use DNNs to detect malicious PowerShell. We also use deep anomaly detection techniques for unusual run DLL and SCH tasks execution. And then, we also look, that's all cool, right? We're using deep learning, generative AI, LLMs, all that stuff. But hey, we also have expert rules that we apply, just basically if-then statements, to domain and IP metadata, because guess what? It works, right? Like, for example, we just know that there's certain ASNs that if you see traffic originating from or data going to, someone should be alerted to that, because generally speaking, they're in, countries or ISPs where, things are not well regulated and attacks originate from. So excellent. So that are the models that we use. So let's go to the demo. So as I pull up the demo, I'm going to stop my share for a second here. Are there any other questions while I pull this up? Here is a Streamlit app that's going to just show off our little PowerShell model. And a couple of things here. So the inference is not going to be super fast. And the reason for that is I'm running this particular model, on an extra small instance, but I'm also invoking it with a cold start. So what happens is when we run our workloads, generally speaking, our models get loaded up, and then we run them against thousands of detections, right? Here, I'm only running against 3. So I have to load up the model, and then, it's going to run, and then it's going to take a little bit of time. But again, it's just how I'm running it. It's not really indictment of, it's not really reflective of the platform. It's just like for this demo and for this purposes, I had to do it this way. So let me put some malicious PowerShell in here that I found, not in our data, but yeah. So what I'll do is that basically I'll give 3 samples at a time. And what I found is that with this particular model, I curated these obviously, but we picked them up. And I'll just kind of go through and why they were found to be suspicious. So I hit submit here. And again, this is the nice thing about the platform, right? Is that this particular platform allows me to create basically something that I can then share with our threat, hunt team, as well as our, threat research team as well. So here we go. Again, this is something you probably don't want running on your systems. Is basically we have a random IP here that's downloading a TXT file and it's going to execute it. Again, this is something that we see a lot of adversaries do. This is great. This is an encoded PowerShell command, but not all encoded PowerShell commands are malicious, but they tend, it's a nice way that if you have something relatively complex, a way to run it easily, either as an administrator or as a malicious adversary. But what you can see here is what this person has done is that basically they are downloading something from the internet. And they're using a lot of, again, PowerShell, all this stuff is valid, right? Even administrators we've seen at, at different customer sites will do things like, for example, what's a good one here, right? They'll use some of these commands like get bytes or, 2base64 string. But what's interesting is that adversaries tend to have a different kind of fingerprint or behavior in using them. So they tend to use certain APIs more frequently, and that's how we're able to detect them, right, with this particular model. And then here again, we have an IWR that's going to download this. I don't know. It's very interesting. This might be an internal red team test, or maybe they stage something locally. I got this one off BT, but basically, right, they have basically this PowerShell script, and then they execute it with IEX. So those are 3 malicious examples. Let me put some benign samples. And again, what you'll see is that, and again, this is the tricky thing about using, doing machine learning modeling is that, for cybersecurity is that it's really hard to get a representative data set. So I have at least the benefit that we have multiple customers, and what I'm able to do is use, their particular data to, train across different, I can train across different customers and really bring insights holistically about sort of what is malicious look like, what does benign look like, and really those particular trends. So here, what I'll show is basically we have, again, this is something we see often, sort of remote signed, run this particular PowerShell from different directories. And what we'll find is that generally speaking, the model does the right thing and sees that the classification is probably benign. So this is probably a better example of the complexity that you can see. So Delphix is a DevOps solution. And as you can see, they've put in a relatively interesting PowerShell snippet here. And what we're able to do, again, is that what we find is that administrator software tend to use different, even though they may use the same APIs that malicious actors use, right? They tend to use them in different ways. And we're able to kind of suss out, okay, this type of invocation with these APIs, with this ratio of different commands tends to be benign. Whereas, if we go back to the malicious PowerShell, they tend to prefer different API commands and things like that. So were there any samples that we can put in and, put my ego on the line here? It would be good. I'm going to show a false positive. I thought I had copy pasted it. I'll bring it up here. And and this is the other thing for all the data scientists out there, it's tough. It's tough, right? Because even some of the behavior that we see, perfectly benign processes, they can fool your models and can be very difficult. And then going back to what you're saying, Jade, about, fidelity, it's really understanding the limitations of your model and really going back to think okay, what can I do differently to, make sure that this is false positive averse, or maybe just have to understand that, look, the model is going to have limitations. And that's fine. It's just understanding what those limitations are and wondering, what is that cost benefit, right? Is the cost of running this particular alert worth, the benefit of actually detecting something malicious, right? So that's the things that that one of the important calculations, particularly when doing cybersecurity modeling, because it's not just oh, hey, you can just throw a scikit-learn at it. You can run or TensorFlow or OpenAI, if I just like create a prompt to say, is this malicious, it's just going to happen to work magically. No, usually there's some amount of pain and frustration that's required. So I think let's look at this one. Okay, so this particular software right here, again, is, what is this? This is Nessus, I believe, right? So yeah, Nessus. I think I'm saying that correctly. So this is a legitimate software that will run on your system. But again, what's interesting is it's using invoke REST method, which is a favorite of attackers, right? It's using get, and it's pulling down data for itself, right? That's going to use for monitoring, right? It's doing a lot of funky things here. So one thing I realized, I was wondering why this got misclassified. And the reason is I actually I have an allow list for Nessus commands, right? So that would be if I could say one thing, one parting word of wisdom, it does help with that data set curation, that anything that you can do to make the model's job easier. Like, for example, I know that anything that looks like this, that has Nessus command and that's hitting 169.254 addresses, right? It's benign, right? And I mean, I can put it in my training set. I can try to detect on it, but it's probably going to cause the model lots of fits. Whereas the simpler solution is to say, look, right, what is known benign behavior? What's left over? Add it to a malicious data set of your choosing, right? And then train the model. So this is an example where, again, this shows kind of like it is very difficult to, just outright be able to say something is malicious, right? And having that contextual knowledge, knowing what kind of software runs in your environments is super critical to then be able to mine these detections for those actual malicious samples. So yeah, here's an example of a false positive.
As you've been putting this together and building all of it out, are there any lessons learned that you can help other people if they're looking to do similar things?
Oh, absolutely. I think having a pattern, right, for deployment. So even though we say, I told you, I was like, hey guys, you can bring whatever library you want. It's all good. It's all gravy. But having a single pattern, and particularly the pattern that we have, which is to put the machine learning as user-defined functions that then we can call from procedures and schedule as procedures, I think is absolutely critical. Also, just be aware that, like, look, a lot of the whole promise of deep learning, and then also with this generative AI, is that, there's no need for feature engineering and that, like, the model will figure it out. And what happens is that the models are absolutely more sophisticated, right? You can get great answers. Everyone's tried, Chat GPT here, and it does works well, but it doesn't work well all the time, right? And really, it's understanding, what are the limitations of those models, and understand, like, okay, here is what I'm trying to, this is the attack surface that I'm trying to target, right? Realistically, what can I actually understand and capture so that I don't create basically a random noise machine with my particular model. So regardless of how complicated the model is, because trust me, I love a good, right now, I love sentence transformers, right? I've been using them to help kind of understand and normalize our event data, right? But the thing is, at the end of the day, it still requires some domain expertise and understanding of the underlying behavior that I can't just outsource all the thinking to the model, right? It really does require you to curate it, understand what the limitations are, and then be able to account for that in whatever final product that you have.
I do have a question. We're doing PowerShell demo right now. We do have a malicious JS. If that is anywhere possible, but I did qualify this with this is live and a demo, and not sure if you have things spun up yet.
So this is, can we table that? I'd love to come back to that. So I don't want to see the sample, and whoever sent the sample, what I would love is, let me, I can actually train that up. That's actually on my backlog of things to do. That might be another thing, Jade, is having a good backlog of the models that you want is very important. But yeah, I'd love to actually see if I can detect that. So give me 2 or 3 weeks. Maybe we can throw it in another threat detection. But I appreciate it. Yeah, I won't be, I have something, but it won't, unfortunately, I can't really show it, like, to get to it. Oh, yeah, it's just, yeah. But
no worries.
I appreciate it. I want to get tested. I want to get tested on it.
All right, so go ahead and send us the malicious JS, and either in part 2 or part 3, maybe at the end, we'll show that one.
That's right. So I know what I'm doing this weekend, right?
Yeah.
in the kids to soccer and also train my JS model. I like it.
Train those models.
That's what they pay me for. Well, it has been an absolute pleasure working with you guys and talking to you. And again, you know where I am. You'll see me again shortly, and look forward to our next conversation. Thank you so much.
Thank you, everyone. And just remember, part 2 and part 3 are coming, where we're going to be looking at the tuning, and then part 3 with the health. So definitely a deep dive into that. We're going to test Mike on his data models for malicious JS. We will do that eventually. Please send that over. If you don't send it over, we can't test him. Maybe he'll go test himself on it. And then we will be sending, for all of you who joined, we do have some detections that we'll go ahead and send you that you can use in your environments. Thank you all for joining, and look forward to seeing you for the next detection dispatch.